Welcome to this explainer. When we picture modern warfare, we usually imagine massive fighter jet dogfights, right? Just sheer brute force. But right now, a fundamental shift in asymmetric warfare is unfolding across the Persian Gulf. Today, we're diving into exactly how Iran's radar-killing campaign is systematically neutralizing U.S. missile defenses across the region. And the crazy thing? They aren't doing it by overpowering them. They're doing it by blinding them.
Take a look at this number. $1.1 billion. That represents the estimated cost of just a single ANFPS-132 upgraded early warning radar. This thing is a massive, highly sophisticated piece of technology stationed at Al Udeid Air Base in Qatar, and it can detect threats up to 5,000 kilometers away. But recently, reports indicate this billion-dollar asset was destroyed in a targeted strike. So you might be wondering, why target a radar instead of, say, a runway or a command bunker? Well, it's because this conflict is not your traditional war of brute force. It is entirely a war of sight.
To really deconstruct this highly complex theater of war, our explainer today is broken down into 5 key parts. 1. The new systems war. 2. Blinding the defense shield. 3. Swarms and smart missiles. 4. The interceptor math problem. And 5. Global economic shockwaves.
All right, let's jump right into part 1, the new systems war. To really grasp what's happening here, we have to fundamentally change how we view this conflict. It's not being decided by fighter jets squaring off in the sky. It's what analysts call a systems war, decided by the deliberate destruction of networks. For decades, the U.S. strategy relied on overwhelming technological superiority, basically assuming that heavy air bases across the Gulf would just guarantee regional security. But Iran, they prepared for a completely different, much longer war. Over 30 years, they buried their infrastructure deep underground and amassed thousands of cheap drones and missiles. It's the ultimate asymmetric bet, fielding thousands of disposable munitions to bleed out multi-billion-dollar fixed networks. Because while a short war favors technological superiority, a long war absolutely favors resilience.
Observers note that there are 3 compounding pressures completely reshaping this balance of power on the battlefield. First up is blindness, caused by taking out those early warning radars. Second is enhanced visibility for the attackers, who are actually utilizing global satellite navigation systems, like China's Beidou network, to guide their strikes. And third is the brutal attrition of really expensive interceptor stockpiles. Together, these forces are just exposing the extreme fragility of a regional security architecture that was built way back after the Cold War.
Okay, moving on to part 2, blinding the defense shield.
Let's look closely at the foundation of the strategy, which is all about knocking out the eyes of the defense network. This relies on a military concept known as SEAD, that's suppression of enemy air defenses. By executing SEAD missions, like the strikes we saw in Operation True Promise 4, Iran intentionally targets these static, high-value radar sensors. Actually, the Islamic Revolutionary Guard Corps has even referred to this campaign as creating a dark night for America's eyes. They know perfectly well that the entire U.S. layered defense network, from Patriot batteries all the way to THAAD systems, completely relies on these radars to see incoming threats and queue up their interceptors.
When you break down the reported targets, the sheer scale of this campaign becomes incredibly clear. Beyond that $1.1 billion radar in Qatar we talked about, there have been strikes on AN TPY-2 systems. Those are the critical radars for THAAD interceptors in Jordan and the UAE, valued at roughly $300 million each. Over in Bahrain and Kuwait, high-value fixed surveillance systems like the FPS-117 have been hit too. Reports indicate multiple billions of dollars in sophisticated infrastructure have been damaged or destroyed. And when these nodes fail, the network develops blind sectors. It essentially forces the defensive systems to react only after missiles are already well into their flight path.
The impact on warning times here is just devastating. Before the radar degradation, defenders had several minutes to track a launch. Now, that window has shrunk to roughly 90 seconds. 90 seconds! This tactical shift is absolutely crucial because a minute and a half is barely enough time to detect a launch, confirm the threat, assign interceptors, and actually fire. It dramatically reduces the success rate of the entire defense shield.
And the tragic, real-world result of this compressed warning time happened on July 17, 2026. Precision strikes managed to penetrate the blinded defenses at Muwafaq Salti Air Base in Jordan. The missiles reportedly struck living quarters and administrative infrastructure, resulting in the deadliest single strike for U.S. forces since this renewed war began, with Central Command confirming American casualties. It highlights a really grave reality, how quickly losing sensors translates directly into a loss of protection. Which brings us to Part 3, Swarms and Smart Missiles.
So now that the defense shield's warning time is crippled, we really need to understand exactly what is slipping through the cracks. The attacking strategy relies heavily on a rapid-fire saturation tactic. Step 1. Launch a massive volume, like 100 to 200 cheap, loitering drones, just to completely overwhelm and saturate the remaining radar channels. Step 2. Exploit multi-directional, low-altitude gaps. Remember, the U.S. defense grid is highly optimized for high-altitude ballistic threats, not swarms of low-flying drones. And finally, Step 3. They fire advanced, smart ballistic missiles precisely when the defense systems are totally distracted tracking that drone swarm. It's a classic misdirection play.
And let's be clear, these aren't your grandfather's ballistic missiles. They're equipped with MARVs, maneuverable re-entry vehicles. Missiles like the Fatah-1 come equipped with movable nozzles, and the Khyber-Shakhan uses special lateral shift fins. What this means is they don't just fall in a predictable arc, they perform unpredictable terminal maneuvers. They literally shift sideways right when defenders have the absolute least reaction time. Plus, according to intelligence reports, they're using Russian and Chinese satellite intelligence to achieve pinpoint precision.
Because of this compounding strategy, blinding the radars, then launching massive drone swarms, and finally deploying evasive MARVs, the shield is leaking. Defense analysts note that during these coordinated barrages, 10 to 20% of munitions are successfully penetrating even the most robust U.S. and Israeli defenses. Even an 85% interception rate, which sounds pretty great on paper, still means that 15 out of 100 lethal munitions are getting right through to their targets.
Now for Part 4, the interceptor math problem. This brings us to the financial asymmetry of this conflict, which is honestly a massive mathematical nightmare for the defense. Consider this. An Iranian Shahi drone costs a few $1,000s to produce. That is roughly the price of a used 2010 Honda Civic. On the flip side, a single U.S. THAAD interceptor costs about $12 million. So the U.S.-led coalition faces this totally unsustainable economic dilemma where they have to routinely shoot down $2,000 drones with $12 million interceptors. You literally cannot win that math equation long term.
This creates a brutal attrition crisis. In the early days of the war, defenders could afford to fire 3 or 4 interceptors at a single incoming threat just to guarantee a kill. But as the war drags on and stockpiles rapidly deplete, well, the math changes. With radar eyes going dark and magazines running dangerously low across the Gulf, military commanders are forced to make some agonizing choices. Do they exhaust their multi-million-dollar interceptors immediately, or do they let some missiles slip through to hit their targets? It's a war of industrial attrition, and the defense grids just weren't optimized to fight this way for months on end.
Finally, Part 5, Global Economic Shockwaves.
So, what does all this mean? Why does a localized tactic of destroying military radars matter to the rest of the world? Well, because the domino effect is astonishingly fast. On day 1, radar networks and military tanker aircraft are targeted. By day 3, seeing the security umbrella fail, maritime insurance markets immediately pull their coverage for commercial vessels. By day 7, without insurance, oil and gas shipping in the vital Strait of Hormuz effectively halts. And because global supply chains are so tightly wound together, by month 6, you start seeing severe global agricultural disruption. When the security mechanisms assumed to protect the Persian Gulf fail, the crisis rapidly cascades from a tactical military loss into a complete shutdown of the global economy's operating system. The macro impacts here are just staggering. We're talking about tanker flow dropping from 80 ships a day down to just 1 or 2. Energy prices surging from $71 a barrel to near 100. Entire commercial aviation sectors suspended in places like Kuwaiti airspace. And crucially, because a third of the world's nitrogen fertilizer and 20% of global oil transit the Strait of Hormuz, this tactical blinding of U.S. radars ultimately ripples outward to threaten European energy security and global food supplies. It leaves us with a stark realization and a really vital question to think about. When billion-dollar defense networks can be paralyzed by cheap drones and precision strikes, what happens to global security when the invincible shields of the modern era are systematically blinded? It proves that in a modern systems war, you don't actually need to punch harder than the heavyweight. You just need to blind them. Thank you for joining me for this explainer, and I hope this gives you a much clearer picture of the unseen war unfolding today.